Hi, everyone. Hope you're doing well and enjoying the Spinnaker Summit. My name is Drew Horn, and today I'm going to talk a little bit about how teams using Spinnaker in their DevOps tool chain can leverage Sumo logic and some solutions that we have here to benchmark and optimize their software delivery performance. So quick background about me, a little internal meme I've been unable to escape, so just leaning into it. I work with our customers, partners, and Sumos to help grow and foster our apps and integrations ecosystem here at Sumo Logic. Just quick little background about Sumo Logic. We're a machine data analytics platform, and we ingest logs, metrics, traces, and other events into the platform and help extract value out of that data. And today, I want to talk about some value that we're extracting out of data emitted from the CI/CD process. So before I jump into the solution, I wanted to talk about some of the challenges that have led us to develop this solution. Just three key areas I want to touch on real quick. The first is the CI/CD pipeline. So we're all familiar with the various stages of the pipeline, planning, developing, building, testing, getting code out the door. But the challenge that we see practically is that teams are implementing their pipelines differently across an organization. This isn't necessarily a bad thing. It's just that different tools and technologies need to be built and deployed differently. If I'm building and deploying an iOS app, that pipeline is going to look a lot different than a team that's responsible for maybe a collection of Lambda functions. The second is, the teams and the people that are involved in the process of building and deploying software. So, product owners, developers, quality engineers, DevOps engineers, and SREs, right? They're all incentivized purposefully, right, to do different jobs and get code out the door and cover their own bases. However, when teams are trying to come together and optimize the pipeline for the entire organization, it can be challenging for these teams to collaborate properly when there's really no hard data that's backing the current state of the pipeline. What's the current performance of the pipeline? Where are the bottlenecks? What is the data that's calling out these challenges? Without that, a lot of times it can be hard to take these different teams and get them to agree on where the best place is to focus the current efforts for the current quarter and to prioritize accordingly. Another challenge is around the tools involved, right? So one of the things that we see at Sumo is, different teams are using different tools to get code out the door, and that's definitely not a bad thing. I would actually say, it's probably a good thing. I think teams should be able to pick and choose the tools that they want to effectively and reliably build and deploy code and get it out the door into production. The challenge is all of these tools, they emit data differently. The structure of that data is different. They're all collecting different parts of data from the pipeline, and they're not sharing data. And so that makes it challenging when you start trying to aggregate performance data about the pipeline at the organizational level. It becomes a huge problem trying to munge all of this data together and provide insights to help optimize software delivery performance. And so kind of summing up some of these common challenges, right? Teams build and deliver software differently. The DevOps tool chain is fragmented and has data silos, right? These tools only have, parts of the picture, right? Collaboration can be a challenge when trying to drive prioritize organizational initiatives. And that's underpinned by a lack of visibility and data across the DevOps lifecycle and standard agreed upon data-driven metrics and insights. So these three challenges are really kind of the main areas that we focused on for this software development optimization solution. What we're aiming for here at Sumo is to take all of this data from all of these different tools in the DevOps tool chain and enrich that data with some context that's helpful for teams to understand, what environment is this event associated with? What service is this event associated with? What team or product is this event or log or metric associated with? And surface that data in Sumo Logic to give actionable insights to teams. In addition, we normalize all of this data. So we take all of this unstructured data and we map it to a common schema inside Sumo logic automatically. And this allows us to do some interesting correlation, including deriving some key software delivery performance metrics that require data from multiple different tools in the tool chain. And we'll get into that in a little bit. What this is going to enable is faster release velocity for teams, improve reliability and security, and better team collaboration. So talking a little bit more about performance benchmarking, some of the main features that we're focusing on with our initial launch here are the DORA metrics. So we're providing real-time actionable insights for the key 4 DORA metrics, and we're aggregating that all the way up to the organizational level. We're also allowing teams to cut and filter that data by, again, as I mentioned earlier, meaningful dimensions for each team or product or repository or service. Furthermore, the entire solution, as I mentioned earlier, again, is log-based. So we're still retaining all of the original logs that we're ingesting and using to derive these metrics. And so that's going to make it easier for teams from an operational perspective to understand what's going on quickly and perform RCAs as fast as possible. And then finally, with the schema, the solution is extensible. So you can take any of the tools mentioned below here and easily plug them into the solution. This involves a process of taking the raw data that's coming in and mapping it to a common schema. And we'll talk about that a little bit earlier as it relates to Spinnaker. So this is a lot, right? Why even bother doing all of this? I think most people on the call here understand the value related to measuring and benchmarking software delivery performance. For those of you that haven't dug into this yet, though, the State of DevOps 2019 report that was put together by DevOps Research and Assessment, which is now under Google, has done a lot of the work for us, actually. So they put together some pretty astounding statistics here that show teams that are laser focused, elite teams that are laser focused, right, on software delivery performance have a massive advantage over their competitors. They're able to deploy code when compared to low performers 200 times faster. They can get code out the door 100 times faster. They can recover from customer impacting incidents over 2,500 times faster. And they have a 7 times lower rate of deploying breaking changes to production. So this research has really kind of driven these DORA metrics to become really kind of industry standard metrics as measures of market agility and reliability. And so these are 4 really important metrics that we're focused on computing for the software development optimization solution. Just jumping through these real quick. Deployment frequency, for those of you that don't know, that's how often code is deployed to production. The faster, the better. Lead time, we measure that from the time from the merge commit to production deployment. So shorter is better there. On the reliability side, MTTR, or mean time to recovery, this is how long it takes to recover from a production customer-facing incident. Shorter is obviously better there. And then finally, change failure rate. That's the percentage of deployments that subsequently require remediation. So the lower is better there. And then before we jump into a demo, I just wanted to walk through an example with Spinnaker for each of these different 4 DORA metrics and just talk a little bit about the correlation process that I mentioned earlier. So deployment frequency, again, this is a measure of how frequently teams are successfully deploying code. In order to compute this metric, you can take a look at the number of Spinnaker deployments over time and derive that frequency. What we've also done here, though, is we've mapped the associated code changes from GitHub that are tied to these deployments. And that's going to make it a lot easier for teams, when they're looking at failed deployments, to understand very quickly what code changes are associated with this deployment or these particular artifacts that are deployed to production. The next one is lead time. So this is, again, time from merge commit to production deployment. And again, you really need data from your version control system and your CI or CD server in order to compute this metric. And so we're ingesting data, again, just as an example, it doesn't have to be GitHub, but an example here, if you ingest the merge commits events from GitHub, and you correlate that with the completion of a deployment to production, you're able to then calculate the lead time. Moving on to MTTR, this is, again, the time it takes to recover from production incidents. Shorter is better. So here, a lot of the teams that we work with are collecting incident data from PagerDuty, and either they're resolving those issues in PagerDuty and we're calculating the MTTR from the time to open to time to close there. In other cases, right, the incident needs to go through the development team in order to get resolved and rolled forward or rolled back. And a lot of times teams are leveraging Jira to track that work as well, in addition to PagerDuty. So it's important to be able to ingest data from one or even two different systems in order to calculate MTTR. And finally, we have the change failure rate, the percentage of successful deployments to production that subsequently require remediation. And so, again, two different tools that you need to collect data from. You want to grab all of the full set of deployments that are going out via Spinnaker, and you want to compare that with the number of incidents that are being filed in PagerDuty. And that's what we're doing at Sumo to calculate change failure rate. So the next thing I want to do is just provide a little bit of a quick technical architecture overview of the solution, and then I'm going to jump into a quick demo. So a little bit about this particular solution at Sumo. It's different in that we have this data normalization layer that's decoupling the dashboards, some of the example dashboards you see on the right, from the raw data being emitted from the CI/CD pipeline. What we do is we leverage Terraform to go out and configure webhooks for Jira, GitHub, PagerDuty. Teams can go in and install our Sumo Logic Jenkins plugin. We don't have out-of-the-box support for Spinnaker, but again, the solution can be plugged directly into our schema by mapping the raw logs that are coming out from Spinnaker, say from the echo logs, or from configuring a webhook stage in your Spinnaker pipeline, sending that data to Sumo Logic and mapping those deployment events to our common schema. And I'll provide some links to the schema at the end of the chat that you can go check out and understand, what are the different fields associated with our Sumo Logic deploy event that you would need to map to. So this data is exfiltrated from these tools. They come into Sumo Logic, they're parsed and mapped to our common schema, and then these dashboards then read off of that common schema to provide these out-of-the-box real-time DORA metrics and other information about your CI/CD pipeline. So with that said, let's go ahead and jump into the demo. Okay, let's take a look at the SDO solution. Before we jump into the various dashboards, I just wanted to give everyone an overview of the folder structure here on the left so they can understand, what dashboards are available to them. So taking a look at the setup here, we have two high-level dashboards here on the left. We have the DORA metrics overview, which you can see on the right. We'll jump into that here in a second. And we have the pipeline overview. The pipeline overview, which we'll show in a sec as well, is going to show this data a little bit more from an operational perspective. And then looking further up here, you can see these two different folders, right? So we have some drill down charts that are available for each of the 4 different DORA metrics that we talked about earlier. Those are going to provide a little bit more detailed data about the metrics and allow teams to cut that data by various dimensions. And then the same goes for the CI/CD pipeline monitoring as well. We have some drill down dashboards for each of the different phases in the DevOps lifecycle, including alerts, builds, deployments, issues, pull requests, and then pipeline stage monitoring as well, which is something that I'll jump into and explain in a little bit more detail here in a sec. And then finally, we have some reports here on the left that allow you to run a bunch of various different reports that you can share out to the team outside of the context of the application. So let's take a look at the dashboards here. The DORA metrics overview, this is the high level overview that is aggregating all of the DORA metric data across the entire organization and showing that data here in real time. So we have some measurements here that are showing deployment frequency, lead time for changes, change failure rate, and time to restore service, or MTTR. In addition to the actual numbers here, right, we're showing some trend data so teams can understand how is this metric changing over time, right? And then we have some outlier detection here that you can kind of see in this lighter color. And teams can go in and they can configure alerts to identify, to alert teams if these metrics fall outside of these bounds. And these thresholds are configurable as well. The last thing about the dashboard here, you'll see the different colors, the green, the orange, and the red. And these are actually tied to the specific DORA benchmarks, the DORA thresholds that are in the State of DevOps report. So for example, you can see down here on the change failure rate gauge, we have low performing, medium, high, and elite. So green is elite, red means, you have some work to do. Let's jump into one of the drill downs for the DORA metrics. So what we're looking at here is lead time. And you'll see, again, we've got this data cut in a bunch of different dimensions that can be helpful for different people, right? An executive technology leader that's maybe trying to understand, how at an organizational level is my lead time changing? What are the different teams that are maybe doing well? What are the teams that need some help? Should we establish some communities of practice to do best sharing, et cetera? An aggregate view is really helpful for them. But for someone that's on a particular team or focused on a particular service, or even a quality engineer that's focused on making sure that testing is executing quickly and deployments are being sent into the test environment and very quickly afterwards going out to production, right? These different people want to filter this data differently, so we've made that available to them. Some of the different ways that we've cut this data, right? Repos by the slowest lead time. What are the repos that are taking longer? Same with services or teams. In addition, and I'll talk a little bit more about pipeline duration later, how long is it taking for code commits to go out to production through the actual CI/CD pipeline itself? And we've listed out a couple of the different pipelines that we're collecting data from. Finally, we have lead time averaged out daily, and then a similar chart here that shows average lead time by repos. So you can jump in and you can look and see, for each day, what were the average lead times calculated for repositories that actually had deployments that are going out into production. So let's take a look at this data a little bit differently. So we're going to switch over to the pipeline overview. This is, again, one of the other overview dashboards with a little bit more of an operational twist on it. So what you can do here, you can come in and immediately see, what is the pipeline execution trend for each of my pipelines? How many deployments are being pushed out into production over time? And here we have, one pipeline here, but if you're sending in data from 5, 10, 15, 20, whatever 50 different pipelines, that data will be charted out here for you. And then below the pipeline execution, what you see here is, again, kind of a layout of the different DevOps lifecycles going from right to left, from production alerts all the way left to pull requests and issues. So we provide some summary data here for teams to look at and then decide if they want to drill down into some of these different dashboards. Again, we have drill downs for each of these, and we'll take a look at deployments here as an example in a sec. So going from right to left, you can see we have, the top 10 services with priority issues, the last 10 critical alerts that you may want to drill down into. On the deployment side, we show a ratio of failed versus successful deployments. If your deployments have other statuses, right, those can be collected in this pie chart as well. And then we also show the last 10 failed deployments. And you can see here, right, for a deployment to pre-production that occurred, we're also including the link to the original file that was committed, right? And so in this example, we have this linked over to GitHub, but you could easily link this back to Spinnaker. And in this example, right, it just makes it really easy to jump in, and for a particular deployment, I'm already down to the actual changed file, what's been changed, a comma to a period. I guess that, maybe that broke everything, maybe it didn't. But it's really helpful to be able to, look at a deployment information in this previous view, see what occurred, what passed, what failed, and then drill down into the underlying commit associated with that deployment. And then, heading further left, very similar information here, right? I can take a look at build status, aborted, success, pass, failed, what's been going on there, the latest 10 failed builds, and then pull requests as well. So the pie chart here breaks out pull requests based off of the different statuses, what's open, what's been closed and resolved, what's been declined. And then a helpful summary view here shows the top 10 pull requests by time to close. So this is nice. You can come in and see what PRs have taken a long time to close. Has someone not had a chance to take a review and look at a PR? Was the code associated with the PR huge and it took a long time to review? Has there been a lot of rework that had to be done to get this pull request resolved? Those are some things that you can very quickly just drill down into by clicking into the pull request that's been surfaced here in this dashboard. And then finally, we have the issue status. So you can take a look and see what issues are currently open, their status, some trends over time. This is really helpful if you're sending in, bug information, including the top 10 issues that took the longest to close, right? So what bugs have been open that were open for a long time, and why did those take so long? You can drill down and then get additional context into those bugs. A little bit of a different view here. So this is a drill down of the pipeline executions. We call this view the pipeline stage monitoring. And the goal here is to enumerate or list out all of the different pipelines that are running in your organization, and to kind of treat these pipelines almost like an application and trace them and emit some data here about how often are they executing, what's passing and failing, and really, how long are each individual stages within the pipeline taking. This can be really helpful to root out any bottlenecks or things that are contributing to a slower lead time, right? So you can very quickly tell here in this data set, right, what's contributing to a long lead time here. It's the regression tests in this master build test pipeline. And we're also collecting some data from the parts of this particular stage, right? The steps that are being executed inside this regression test. And there's, a ton of data around, what are the 10 slowest steps that are associated with a particular stage. And what you can do here, if we think that regression tests are contributing to the slow lead time, we can filter by this regression tests. And then we can very quickly just come down here and look at our regression test stage, the various steps associated with that stage, right? And then, the duration of time that it's taking for things to execute for each step. So this data, we pulled in from Jenkins, but you could just as easily collect data like this on the different stages of your Spinnaker pipeline from the echo logs, or even you can get crafty and add some webhook stages to your pipeline to collect additional data. One last view I wanted to show here, this is the deployments dashboard. So again, very similar to the other dashboards where you can cut this data by various different dimensions, environment, status, service, team, repository name. These different dimensions are made available through the enrichment process. So, when Spinnaker emits information about a particular pipeline, teams can enrich that event by adding context around, what is the environment that this is deploying to? What service is this associated with? What team is this deployment pipeline associated with, or the original repository? And by attaching that metadata to these log events, or by adding in a webhook to emit this additional context information in your pipeline, Sumo can take all of this data after the normalization process and provide it in the context of filters above. So making it really easy for someone to come in and understand, in this particular example, over the past 24 hours, how many deployments occurred, what was the ratio of the different results. Same with the environments. You can get a one-day comparison of, the count of deployments that succeeded or failed yesterday versus today. And then again, you can cut this data by repository, by service, by team, and then get into a little bit more operational data around the latest 10 deployments. And then finally, one of the other dashboards here at the bottom is the success versus failed deploys. This is giving teams, a really nice visual and trend analysis to understand, are the number of failed deployments increasing with respect to the successful ones, or vice versa? So it's a real nice way to kind of get an understanding of the two different statuses over time to suss out any trends or changes that may need to be addressed. And again, right, so by default, this data is all aggregated across all of the different pipelines, but if there's a particular service that you want to go in and understand success versus failed trends, right, you can go in and type that out, right? And then once you do, that data will be filtered so that you can see, just a view that's helpful for you for your particular service of the success versus failed deploys. All right, everyone, that wraps up our presentation today. I hope the chat has given everyone a good understanding of the DORA metrics, how they contribute to software delivery performance, as well as how Sumo and Spinnaker can help you benchmark and optimize that process to get high quality code out the door faster. If you want to learn more, I've included a couple links below to get up and running with the software development optimization solution. You can check out all the docs on help.sumologic.com. With respect to Spinnaker, the Armory team has graciously hosted some documentation on how to very easily get that data into Sumo Logic, so you can start parsing and mapping that data to the solution. In addition, for anyone that's interested in extending our SDO solution to provide out-of-the-box support for Spinnaker, we have an active hackathon going. This hackathon is opening up the ability for teams to contribute to our existing Terraform template. So we use Terraform, as I mentioned earlier, to set up this solution automatically. And we have support for tools like Jenkins, Jira, Bitbucket, and other CI/CD tools. And we'd love to see, anyone that's interested in extending that, that has set up the solution for Spinnaker, feel free to check it out. And then you can always reach me regarding the hackathon or any other questions on the Sumo Dojo. And you can join this public Slack workspace at sumodojo.slack.com. Thanks again, everyone, for joining, and enjoy the rest of the Spinnaker Summit.